Okay, hello friends. Oh no, I just shook the thing. Okay, hi, let's do some math. This is gonna be fun. So you've got your notes in front of you, 2.6, rational functions and asymptotes. So what we were just doing in chapter 5 was learning how to graph, how to deal with polynomials. Well, we're not talking about polynomials right now. Everything we learned about graphing in section 2.2 and all of that had to do with polynomials. And we are moving on to rational functions. We're going to be looking at asymptotes. It's going to be a ton of fun. Are you ready? So let's see here. Okay, so first thing we have to do when we talk about graphing a rational function, rational meaning with fractions. That's what rational means. Look at the word, let me back it up. Look at the word ratio right here. Okay, that means we're going to be graphing something that's got a fraction in it. So vertical asymptotes, we have to talk about that first. And this is something we've actually already done at length. This is what we did the first week. We started talking about domain. Well, domain is directly related to this word asymptotes. And I think you guys have some experience with this, but let's just double check. Vertical asymptotes are caused by having zeros in the denominator or fractions. So vertical asymptotes are caused by having zeros in the denominator of a fraction, I should say. Vertical asymptotes affect the domain of the function, so that's something that we've dealt with lots. To find the vertical asymptotes, what we're going to do is we're going to set the denominator equal to 0. So that's mathematically what we're going to do. We're going to be setting the denominator equal to 0, which is exactly what we did for domain. So this is going to look very similar. It should. So here we go. Identify the vertical asymptote and the domain of this rational expression. So let's start with the domain because that's something that we've done. If I asked you to find the domain of this, you would go, but Miss Hass, it has a fraction. It's got a denominator, so we have to set the denominator equal to 0 and then solve for x. And this is the value that we want to exclude. We don't want the denominator to equal 0, so we find out when it's going to equal 0 so that we can exclude that value. What that looks like in terms of the domain, if you recall, was we would go like this, open circle, and we'd say it can be everything here and it can be everything here, it just can't be that. And we would write it in interval notation saying negative infinity to negative 2 in union with negative infinity all the way out to infinity. And so we would do something like that. So that's this part, we just found the domain. Now how does that relate to an asymptote? Well, this right here tells us our asymptote. X equaling negative 1, x equaling negative 2 is our vertical asymptote. What that means is when we go to graph this little sucker, which I'm not asking you to do right now, but when we go to graph this little sucker, 1, 2, negative 2, we're going to have an asymptote like this, a vertical asymptote like that. I think this is all familiar to you guys. I think that should be a review for the most part, but I want you to see how it relates to the domain, which is exactly what we've been doing. If you recall, when we were finding the domain, we were figuring out when is the function broken, and so that's what we're doing right now is figuring out when is this rational function kind of broken, and it's broken at negative 2, so it's got a vertical asymptote right there. Okay, so now let's try it again. Do-overs. Says identify the vertical asymptote and domain of each rational expression. So same directions. Let's go ahead and set our denominator equal to 0. Solve, you can either factor that or you can take the square root of both sides. If you take the square root of both sides, don't forget your plus or minus. If you had done this by factoring, you should get x equals plus or minus 2 as well. So now this is what, this tells us our vertical asymptotes. This is what we don't want. So from a domain point of view, if you're looking at this, we've got a negative 2 here and a positive 2 here, open circle going that way, open circle like that. So we would have, our domain would look like this, negative infinity to negative 2, union with negative 2 to 2, union with, oh, am I going off here? Yeah, sorry. 2 to infinity. Bam, nailed it. Okay, so that's what we don't want it to equal. Now in terms of our vertical asymptote, x is going to equal 2. We have a vertical asymptote there, and we have a vertical asymptote at x equals negative 2. Again, not asking you to graph this yet. That's coming pretty quickly. What this would look like is at negative 2, we'd have a vertical asymptote, and we'd have a vertical asymptote here. So That's what's coming. Okay, keep it going. We're doing a great job. Look at us. Woo woo. You guys are probably still on the same page, even though I'm switching pages because I wanted a little bit more space, and I'm cool like that. So, okay. X squared plus 7x plus 12 equaling 0. Hopefully this is making good sense, seeing as how you can't ask me any questions. Identify the vertical asymptote and domain of each rational expression, so same directions. So now I've got to step up my game and factor correctly. I'm going to go 3 4z's plus z's plus z's. And x equals -3, x equals -4. We just ZPP'd it using the zero product property right there. Hold, please.